All right, so here we go. We're going to talk first about solving one-step equations, right, with variable using your addition and subtraction properties. So we're going to be talking about equations. We're going to be talking about solutions of an equation, right? So simple, an equation, it's just math, right? Two expressions, that means two sides. So two things are equal. So you're going to have two things. You're going to have something on each side of the equal sign. And the solution is when you have the variable by itself on one side and you have everything else, usually a number by itself on the other side, right? So we're going to talk about ways to isolate the variable, and we're going to talk about how that works to solve an equation. So you are going to do inverse operations, right? We've talked about this. Inverse operations to move things from one side of the equal sign to the other, right? So if it's addition, you're going to do subtraction. If it is subtraction, you're going to do addition, right? In order to move things from one side of the equal sign to the other. And as always, you have to do the same thing to both sides to keep an equation the same, to keep it equal, right? Everything happens on both sides of the equal sign. For example, looking at this equation, y minus 8 equals 24, right? The opposite operation of subtraction is addition. So in order to move this whole negative 8, everything away from the y, we're going to move it to the other side of the equation. And to do that, we're going to do the opposite operation, which is addition. So we're going to add 8 to both sides. There we go. Right? And so these are going to cancel out, right? Because negative 8 plus 8 gives you 0. So these are going to cancel out. And then this will give us our solution. We have our variable on one side by itself, and we have a number on the other side. And so that is how we have the solution here. You can always check it by plugging in your solution into the original equation. If y equals 32, we'll substitute 32 in for y. 32 minus 8 does indeed equal 24. So that's a good deal. So the same thing works for fractions, right? As you know, with fractions, if you are subtracting or adding, you have to have the same denominator. That's the bottom number. And in this case, we do. So easy peasy, right? So we are subtracting 7/16 over here. In order to get rid of that and get this z by itself, we're going to do the opposite operation again. And here we go with adding 7/16 to both sides, right? When you add fractions with the same denominator, you merely add the numerators together. That will give us 12/16, which reduces to 3/4. Once again, same thing. If you check your solution by plugging it in, right, you do indeed. And once again, 3/4 is equal to 12/16. So 12 minus 7 does indeed give us 5. All right, so you can try this one on your own, right? So as we're working, just pause to do your steps, and then you can hit play in order to see my steps, right? So here we are subtracting 3.2, right? So we're going to add 3.2 to both sides, giving us an answer of 8.8, because once again, these cancel out. And as always, we can check our answer by substituting it back in and seeing that it is indeed the correct answer. Okay, same thing here, right? Go ahead and pause this, try and solve this on your own, and then follow along with the answer. Since we're subtracting 6 from both sides, we're going to add 6 to both sides. A negative 6 plus 6 is going to give us 0. So k is equal to 0. Check our answer real fast. 0 minus 6 does indeed equal negative 6. All right, here's another one to practice on. So here we have subtracting 9 from both sides. So we are going to add 9 to both sides, giving us 25. And we can indeed check our answers. Good job. All right, so here right? In this particular example, we are adding 17 in order to move this positive 17, remove it, right? And get this m by itself. We're going to subtract 17. So it works the same. As long as you have the opposite operation, you get your answer. These two cancel out, and 33 minus 17 equals 16. And you can indeed check your answer by substituting it into the original problem, and you get your answer. So we're looking at the same basic thing here with decimal. Go ahead and give this one a try on your own. Pause the video. So we are adding 1.8 to both sides here, not to both sides. Since we're adding 1.8 to the t, we're subtracting 1.8 from both sides, right? Opposite operation here. 4.2 minus 1.8 does equal 2.4, and these cancel out. And you can substitute it back in and check your answer, right? Once again, still works the same with fractions, right? So in this case, we are going to, if we are adding 1/2 to d, we need to subtract it, right? 1 minus 1/2 does give us 1/2. Plug it in and check your answer. All right, you can try this one on your own. Pause the video and try it. All right, so we are adding 5 to k. So we're going to do the opposite operation. So we're going to subtract 5. We do the same thing to both sides of the equal sign. 5 minus 5 equals 0, so that cancels out. -5 minus 5, we are moving to the left on the number line. So we get a -10 equals k. Plug it back in. -10 plus 5 does indeed equal -5. All right, same thing for this example. All right, pause the video, try it on your own. So since we are adding 6 and t, you know, because it's addition, you can reverse this if you want to and look at it as t plus 6. Either way, you're adding 6 to the t, so we're going to subtract the 6 from both sides, right? 14 minus 6 equals 8. Plug it back in, and you do indeed get your answer. So, as we talked about also, when you subtract something, right, you're adding the opposite, right? So, you have a negative number here, right? And so you are adding a negative number to p, right? So since it's negative, right, we're going to do the opposite once again. So we're going to add 5/11 to both sides of the equation. -5/11 positive plus a positive 5/11 is going to give you a 0, so those cancel out. And then you have 2 plus 5, because when you are adding, it's a -2. When you're adding things with like denominators, you are just working with the numerator. This is a negative here, so -2 plus 5 gives you a +3. And you can plug it in and check your answer. Same thing here. We're looking at the same kind of equation. Because you have a negative here, the opposite of negative is positive. So you're going to add that 2.3 to both sides, right? A -2.3 and a +2.3 cancel out. And so you get your answer. Plug it in and check. Now you can try this one on your own. Pause the video and see if you can get the correct answer. And then come back and play. And so you have a -3/4 adding to z. So you're going to do the opposite operation. This is a -3/4. So you're going to add 3/4. Once again, these cancel out. So it leaves you a z by itself. 5/4 plus 3/4 gives you 8/4, and 8/4 reduces to the whole number 2. Plug it in, check your answers. Same thing here. since we are adding a negative number to x, we are going to do the opposite of a negative, which is a positive. So we're going to add 11 to both sides. These cancel out. 33 plus 11 does indeed equal 44. And as always, you can plug it back in and check. And sometimes, word problems can be difficult. So we'll do one word problem as an example. So over 20 years, the population of a town decreased by 275 people. That means it went down. That's a negative, right? To a population of 850. Write and solve an equation to find the original population. So we're going to use algebra, right? So we're looking at decreasing, once again, negative 275. And after you decrease by 275, you get 850. So we need to find what the original was, right? So the original population, right, subtracting the decrease, and that gave us 850, which is our current population. So we are going to create. So you got P as your original population. You're subtracting because it decreased. Your decrease in population equals your current population. And then we just plug in what we know, right? We do not know the original population. That's what we're looking for. We do know that the original population went down by 275 people. We subtracted it, and we know that gave us 850. So that equals 850. And then we can do what we just reviewed, solve this by opposite operation. And we find out that the original population was 1,125 people, right? One more example like that. A person's maximum heart rate is the highest rate it beats per minute. That's the person's heart should reach. One method to estimate maximum heart rate states that your age added to your maximum heart rate is 220. Using this method, write and solve an equation to find a person's age if the person's maximum heart rate is 185 beats per minute. So we need to make a plan, right? So you add your age to a maximum heart rate, and that gives you 220. So we can think about this again. Age plus your average heart rate equals 220. So plug in what they gave us, which was the maximum heart rate. And we're looking for a person's age. And so now that we have this equation written out, we can do the opposite operation and find out that that person is 35. All right. So now we're going to jump to the solving problems by multiplication and division. So it's very similar into what we just did. Solving one-step equations with one variable using multiplication and division. Very similar to what we just did, right? You are doing the opposite operation. So if you are multiplying by the variable, the inverse of that is going to be division. And if you are dividing the variable by a number, then you are going to use multiplication to solve that equation, right? So here we have -8 equals j divided by 3. So since we are dividing j by 3, we are going to do the opposite operation, which is multiplication. So we are going to have to multiply both sides by 3. You always have to multiply both sides of the equation if you are using multiplication to remove what you are dividing by. So you have to do the same thing to both sides of the equation. That keeps it equal. And here, these cancel out, right? So you get 3 times -8 is -24, and that is j. And in the same way, you can indeed plug it in to check your solution. -24 divided by 3 does indeed equal -8. Same basic concept here. You're dividing in by 6. So in order to remove that 6, you're doing the opposite operation, which is multiplication. 6 times n divided by 6 gives you, right? This is going to cancel out. So you are left with n over here. And then on this side, 6 multiplied by 2.8 gives you 16.8. And that gives us our solution. And once again, plug it back in, right? 16.8 divided by 6 does indeed equal 2.8. All right, you can do this one on your own, pause the video, and then come back for the solution. So we are dividing P by 5. So we're going to multiply by 5 to get rid of the 5 on this side. We're going to do the same thing to both sides. So we're going to multiply 10 by 5. It's going to give us P is equal to 50. And we can plug it back into our original equation. 50 divided by 5 does indeed equal 10. There's another one to try on your own. We've got a negative in this case. Pause the video. All right, so your y is being divided by 3. Opposite operation is multiplication. So we're going to multiply both sides by 3. You have a positive multiplied by a negative, which is going to give us a negative as our answer. Positive times positive equals positive. Negative times negative equals positive. But positive times negative equals negative. And you plug it back into your original equation. Negative 39 divided by 3 gives you your negative 13. That is absolutely the answer. Here's another example you can try. You're dividing C by 8. So you're going to do the opposite operation, multiply by 8. The 8's cancel out. 8 times 7 equals 56. Plug it back into check. And here we go. 56 divided by 8 does indeed equal 7. All right, so in this case, we are multiplying our variable by 9. The opposite operation of multiplication is division. So we are going to divide both sides by 9, right? So 9 over 9 is equal to 1. So 1y is equal to y. 108 divided by 9 equals 12. And you can still plug it back in. 9 times 12 does indeed equal 108. All right, here we go. In this case, we are multiplying v by negative 6. So since division is the opposite operation, once again, negative 6 divided by negative 6 is 1. 1v is just going to give us v. Negative 4.8 divided by negative 6 gives us a positive 0.8. Same thing. Positive divided by positive gives you a positive. Negative divided by negative gives you a positive. But a negative and a positive here would have given us a negative, right? Plug it back in. We have our answer. Here's the same thing. Give it a try on your own. All right. So in this case, we're multiplying 4 by C. So the opposite operation is division. We're going to divide both sides by 4. These 4's cancel out, leaving us with C by itself. 16 divided by 4 is equal to 4. And we can plug that back in to our original equation. 4 times 4 does indeed equal 16. Same thing here. All right, give it a shot. We had a decimal here. Give it a shot on your own. All right, in this case, we're multiplying y times 0.5. So opposite operations, we're going to divide by 0.5. These cancel out, leaves y by itself. Negative 10 divided by 0.5 is equal to negative 20. Plug it back in. Right, 0.5 times negative 20 does indeed give us a negative 10. Here's another example. We're multiplying 15 by k. So we're going to divide. That's the opposite operation. Make sure you do the same thing to both sides. And we're going to get k is equal to 5. Plug it back in. And we are good to go. Right? Now, when we're working with fractions, it's important to remember that if you divide by a fraction, you multiply by the reciprocal. And that is how you divide by fractions. So in that case, here's an example of that. We are multiplying w by 5/6. So in order to do that, we need to divide by 5/6. And when we do that, we multiply by the reciprocal. Switch the numerator to the denominator. These cancel out, right? Because you would multiply straight across. 6 times 5 equals 30 as the numerator, and then 6 times 5 as 30 as a denominator, and the 30 over 30 would equal 1, still leaving us with our w by itself. when you think about multiplying by 6/5 times a whole number of -20, you think of -20 as -20 over 1. So 6 times -20 is 120. And then you would divide 120 by 5, and you would get your answer of 24. -24, because you are multiplying a negative and a positive, which gives us a negative. You can plug it in and check it. 6 times -24 does indeed equal -20. Okay, here's the same situation. So try this one on your own. All right, so we are multiplying 1/8 times z. We're going to divide, right? Because that's the opposite of multiplication. We're going to use the reciprocal once again. The reciprocal of 1/8 is a whole number 8, because it would be 8 over 1. And that would equal, 8 times 1 is 8. 8 over 8. These cancel out, leaving our z by itself. On this side, we multiply 8 times 3 gives us 24 over 16, and that reduces to 3/2. Plug it back in, and it works just fine. Same thing here. Give it a try. The more we do fractions, the more comfortable we will be with fractions. So in this case, we are multiplying 1/5 times b. So we're going to divide by 1/5, which means we're going to multiply by the reciprocal. The reciprocal of 1/5 is 5 over 1, or whole number 5. And this way, this cancels out, leaves b by itself. And this is a positive times a negative. So we're going to get a -5/4, which could be changed to the mixed numeral 1 and 1/4, -1 and 1/4, right? Plug them in, and it fits. Okay, you can also write it like this. In this case, we are multiplying 4/6 times j, right? If you write it like this, it's still the same thing, right? As 4/6 j. It can be written like this, right? Because it'd be the same as 4 over 6 times j over 1. And j over 1 is the same as j by itself. So if this is written like this, don't let it confuse you. Right? Write it the same way, solve it the same way, multiply by the reciprocal, and we get our answer of, right, this will equal 12 over 12, which reduces to 1. And you can check that, and you get your absolute answer. So, once again, same kind of problem, right? 1/6 times w. We're going to multiply by the reciprocal, which is going to be 6 over 1, or 6. These cancel out, and you get 712 as your answer, because 6 times 102 is 712. And once again, 1/6 times 712, that would equal 712 over 6, which would give us that 102. Now let's look at some word problems again. Ciro puts 1/4 of the money he earns from mowing lawns into a college education fund. Always a good idea, saving for college. This year, Ciro added $285 to his college education fund. Write and solve an equation to find how much money Ciro earned mowing lawns. So he puts 1/4 of his money away, which means 1/4 of his money was $285. So we'll figure out, right? 1/4 times his earnings equals his college fund, right? So what's our equation? 1/4 times your earnings, your money, equals what you're putting in for college. We know what he put in, so we know that. So we're going to, basically, it would be 1/4 m, and you could write that as m over 4 equals 285. So we're just going to, since we're dividing m by 4, we're going to do the opposite operation, which is multiply. Multiply both sides by 4. These cancel out. And we find out that during the summer, Ciro earned $1,140, and 1/4 of 1,140 gives us our 285. It's a good amount of money cutting grass. All right, so we can try one more of these. The distance in miles from the airport that a plane should begin descending, the distance from the airport that the plane should begin ascending, so how far away from the airport the plane should start going down, divided by 3 equals the plane's height above the ground in thousands of feet. A plane began descending 45 miles from the airport. Use the equation to find out how high the plane was flying when the descent began. So we're going to be able to find out how high in thousands of feet, right? Distance divided by 3 equals the height in thousands of feet. So we're going to write an equation. Distance divided by 3, d over 3, is going to equal your height in thousands of feet. So what do we know? It was 45 miles, right? Divided by 3 gives us 15. That's h, right? But once again, that's in thousands of feet. So it's 15,000 feet, right? So that concludes the basics of algebra, basically. Solving equations by adding, subtracting, and solving equations by multiplication and division.